Hey, ladies and gentlemen. Welcome back for 6.2. I'm going to start with the bell ringer up here. I'm going to take care of my exponent. Actually, I'm going to take care of what's inside parentheses first. It looks like it's x to the negative second, which is then squared. So this will be x to the fourth times, x to the negative fourth, power to the power multiply. So which would be x to the 0, which is 1. There's your bell ringer for chapter 6.2 at the start. So, what are we talking about in 6.2? How do we evaluate a polynomial function? That sounds exciting. Okay, so before we jump in here, let's talk about the parts of a polynomial that we'll be referring to as we go through the lesson. The leading coefficient, when this is in standard form, okay, the leading coefficient is the number that's all the way out front. In this case, it's the negative 7. Your degree of the polynomial is the highest exponent, which should be in the front when it's in standard form. So their degree of this polynomial is 4. Our constant term is negative 6. It's whatever's on the end with no variable. So when we go through here, we say, okay, a constant, f of x equals 3. Just give me a number. That's a constant. A function that is linear would be, say, 2x plus 1. Anything where the highest exponent is 1. A quadratic is what we've been working with in chapter 5. It could be x squared plus 3x plus 4. A cubic is anything to the third power, as simple as x to the third. And a quartic could be 5x to the fourth plus 3x cubed minus 2x squared plus x minus 5. The key here with a quartic is that I have this guy, x to the fourth, as my highest degree. Now, so first part that we're going to practice here is we're going to substitute x in for 2, 2 in for x, and then we're going to solve for y. So this is going to be y equals 2 squared minus 6 times 2 plus 8. Order of operations, exponents is 4, then multiply, which will give me 12, and then I'm adding from left to right. So this is negative 8 plus 8, which we know is 0. Number 2, let's go ahead and put in our 2 here. 2 to the fourth plus 5, 2 to the third plus 5, 2 squared minus 5 times 2 minus 6. First order of business, 2 to the fourth is 16 plus 5 times 8 plus 5 times 4 minus 10 minus 6. By a little more space here. This is 16 plus 40 plus 20 minus 10 minus 6. These two guys make 56. These two guys are going to make 10. And then I got 56 plus 10, which is 66 minus 6, which is 60. There you go. So 2 is finished. All right, moving down to 1 through 4. Says use direct substitution to evaluate the polynomial function for the given value of x. So all I'm doing is putting in positive 5 for every x here. So f of 5, as I'm putting 5 in for x, equals 5 squared minus 5 plus 4. So f of 5 is 25 minus 5 plus 4. 25 minus 5 is 20. 20 plus 4 is 24. So what this says is when x is 5, y is 23. So that's a point on the coordinate plane. Number 2, I'm going to put in negative 1 this time. So f of negative 1 equals 10 times negative 1 to the fourth plus 5 times negative 1 to the third plus 4 times negative 1 squared minus 7. F of negative 1 is 10 times 1. Because negative 1 to the fourth is 1. 5 times negative 1, because negative 1 cubed is negative 1. This is 4 times positive 1 minus 7. Continuing down here, I have 10 minus 5 plus 4 minus 7. So f of the negative 1, when it's all said and done, will be 5 plus 4, which is 9. 9 minus 7 is 2. So f of the negative 1 is equal to 2. Moving down to number 3. I'm going to choose purple for this problem. Again, putting in negative 3. So this is negative 3 squared with a negative 1. f to the negative 3. This is negative 9. Because negative 3 times negative 3 is positive 9, but I had a negative in front. Minus 21 minus 9. So basically, it's a one big addition problem of negative numbers. So it's negative 30, which is then negative 39. Right, x is 4. So here we go. F 4 equals negative 6 times 4 to the 4th, minus 3 times 4 to the 3rd, minus 5 times 4. 4 to the 4th. Let's see here. 16 times 16 is 256. 4 to the 3rd is 16 times 4. What's 16 times 4? 64. And I got minus 20 on here. So I'm going to actually multiply these here. And it's going to be a negative number, 36, 33, 12, and 15. And this is going to be 12, 18, 19, negative 192. And again, it looks like one big addition problem with my negatives. So we're looking at 2 plus 6 is 8, 2 plus 9 is 11, 11 plus 3 is 14, 1 plus 1 is 2, 7. So it looks like negative 1,784 is what I'm ending up with. So there's your first page. We're going to see on the back here in a second. Okay, so that's direct substitution on the front. On the back, we're going to talk about synthetic substitution. Trust me, this will make your life easier in the long run. Go ahead and take a look at this on your own time. I'm going to spell out what you're going to do here in a couple of examples so we can save time. And I'll walk you through this in a manner that you can kind of follow what they're doing. When you do synthetic substitution, or whatever you're substituting in, which is 2, that goes in the top left corner. And being organized is very important. So 2 is in the front corner, and I'm going to follow that by 5, because this is my first number, followed by 4, followed by 8, followed by 1. Now, if they skip a power here, you need to have a 0 in there holding that place value until you get to your next number, all the way down to your constant. Now, the first number you don't touch, you bring it down. 2 times 5 is 10. Add these, you get 14. 2 times 14 is 28. 28 plus 8 is 36. 2 times 36 is 72. So when you do this, f of 2, you'll get 73. You can check that by substituting it in. But you have to follow directions. They're asking you to do synthetic substitution. So you can't do direct substitution. You would have to do it this way. And you would get 73. Coming over here for number 2, we're putting in negative 1 this time. My leading coefficient's 2, followed by 1, negative 3, 5, and there is no constant, so you need to put 0 to hold this constant's place value. You can't just end with the x term. So bring down your 2, multiply, add, multiply, add, multiply these two, get 2, get 7, negative 7, you're left with negative 7. So f, when you put in negative 1 to your function f, your y will be negative 7. And there's your first 2 problems. Welcome to the wonderful world of synthetic substitution. All right, we'll jump into 3 and 4 now. Go back to blue. Here we go. 2, I got negative 4. They skipped x squared. Your x term and then your constant. Notice they skipped an x squared here, so I need a 0. That's where that's coming from. So bring down your negative 4, multiply, get here. Add these, multiply. Add them, multiply. So, f of 2 equals negative 31. Right? Moving here. Negative 5 is next. We got 1, 3, 6, and negative 11. Nope, didn't switch, didn't move anything. I know I'm good. Every value is held. Got negative 5, got 10. Get, ooh, what's that? 50 times 30, 80. It'll be negative, so I'm getting negative 91 in this case. So that's one of the larger ones so far. After negative 5 is negative 91. Let's just check this. Bring down the 1, multiply, yep. Add them, yep. Multiply, yep. 16, yeah. All right, and 5 and 6. 5 and 6. I'm going to do a pink here to start. I'm going to rewrite my 5. I got 2, negative 1, 6, 0. Notice there's no constant, so I need a 0 there. I got 10, which is 9. This is 45. This is 51. 255. And that's my final answer. Final answer. Yeah. Who wants to be a millionaire? 255. There you go. All right. Picking up steam now, I hope. So 10 is your top left. 7, 9, 3, 0. No constant. Need a 0 to hold that constant. Bring down the 7. 10 times 7 is 70. Get 79. Multiply those. 790. So 793. Multiply that. 7,930. That. So this one, f of 10, will yield 7,930 as your number. There's section 2, guys. It's direct substitution and synthetic substitution. You should eat this guy up, spit him out, and get an A. Hopefully that will work for you. Questions? Email me. Fire away, guys. Hope you have a good day. See ya.